everyone, welcome to our new topic, topic 7, where we will be learning about polynomials and factoring them. Today we are going to focus on adding and subtracting polynomials with a little bit of factoring. So let's go ahead and get started. We're going to go ahead and skip down to the vocabulary. These are just some examples you can refer to when we're finished. But a polynomial is an expression that has multiple terms. And you can break that down into a monomial with one term, a binomial that has two terms, a trinomial that has three terms, and then a polynomial we refer to as anything that has more than three terms. Down here, we're going to be talking about the degree of monomials and polynomials, and I'll explain that as we get further into our lesson. And then the leading coefficient is the first number after you have written your polynomial in standard form. And then standard form is from greatest degree to least degree, and I'll show you what that is as well. Okay, so let's get started on our examples down here. We are going to try to figure out what the degree of each of these monomials are. And so the way that you do this is you add up the number of exponents that you have. So we have 4 as an exponent for x. We have 1 as our exponent for y. Even though we can't see it, we know there's a 1 there. And we have 5 as our exponent for z. So what we do is we just add those up. So 4 plus 1 plus 5 gives us 10. So the degree for this monomial is 10. And that's pretty much all you have to do here. For the practice right here, we have one variable of x, and we know that that exponent is 1, even though we don't see it. It's the only variable, so the degree for this monomial is 1. In this example, we have 1 plus 3 plus 2. And so the degree for that monomial is 6. Now with something like this where you don't have a variable, then your degree would be 0. Okay, all right. We will go ahead and move down to the next section. We are going to rewrite each polynomial in standard form and then find the leading coefficient. In order to write it in standard form, you need to take each term, each monomial within the entire polynomial, figure out what its degree is, and then you will order those monomials in order from greatest degree to least degree. So let's see what that looks like here. In looking at just the 3x, my degree for 3x is 1, and the degree for 4x squared would be 2, because my exponent is 2. So in writing this in standard form, my 4x squared will go first, and my 3x will go second. So I would write this as 4x squared plus 3x. My leading coefficient is the coefficient of my term that has the highest degree. In this case, this term has the highest degree of 2, and the coefficient is 4. That would be considered my leading coefficient. And then the name of this polynomial, because there are two terms, it is a binomial. Okay. All right, let's look at this practice one. I'm going to order them from greatest degree to least degree. This has a degree of 2, a degree of 0, and a degree of 1. If you don't remember that, go rewind this a little bit and go up to the top to where we talked about what a degree of 0 is. So I'm going to order these. So I have 5x squared, that's my greatest degree, and then plus 7x. Now on this part, I want you to be very careful because the sign that you take with the term is the sign that's in front of the term. So in this case, because 1 has a negative in front of it, whenever I write, or subtraction, whenever I write it, I will write it as minus 1. My leading coefficient is 5. And since this has 3 terms, the name of the polynomial is a trinomial. Okay, Down here in this next one, I have a degree of 0, a degree of 2, a degree of 1, and a degree of 3, and I'm going to rewrite this in standard form. I have a positive 7x cubed. Okay. I have a positive 5x squared. I have a negative x and a positive 8. So that is in standard form. My leading coefficient is 7. And since this polynomial has more than 3 terms, we just refer to it as a polynomial. Okay. Right, moving down to the last practice problem on page 1. When you have multiple variables, make sure that you add up all of the degrees. So this one has 2 plus 1, which is 3. This one has 4. This one has 0. And this one has 2, 1 for A and 1 for B. So my first term is going to be the negative 2b to the 4th power. Then I'm going to have positive 3a squared b. Then I'm going to have a negative 6ab and then a positive 5. Okay. My leading coefficient is negative 2, and the name of my polynomial is just polynomial. Okay. All right, so that is page 1, just identifying your polynomials. And we're going to go now to adding and subtracting polynomials. Okay, so this is just like combining like terms. There's really no difference other than when we combined like terms before, it was basically one variable raised to a smaller exponent. In this case, we have multiple terms, sometimes raised to multiple exponent or have multiple different exponents and, variables raised to different exponents. That's what I'm trying to say. So I am going to show you how to do this here. When I add my polynomials, I like to write them in columns. You don't have to do that. I can show you a different way, but this is what I like to do. It just lines them up nicely and to where I don't make any errors. So the first step says to set up your problem in either standard form or columns. In both cases, make sure your terms are ordered from largest degree to smallest degree. So I'll show you what that means. I'm going to take this first set here, this first polynomial here, and I'm going to write it in standard form. Okay, I have negative 8x cubed plus 4x squared plus x plus 1. Okay, and now what I'm going to do is I'm going to line up my my monomials that have the same exponent raised to the same power underneath its like term. Okay, so what does that look like? Well, I have a negative 2x squared right here. So I'm going to put it under the 4x squared. Those would be like terms. I can combine those. So I put minus 2x squared. Then I have a positive 7. This is at 0 degrees, so I put it under my term with the 0 degree, so plus 7. And then I have a positive 3x cubed, so I will put that under negative 8x cubed. Okay. And so then I can add these just like I would an addition problem, like we did in 2nd grade where we added 7 plus 2 when we wrote them in columns. So this is a negative 8 plus 3. So I have a negative 5x cubed. Okay. This is a positive 4 minus 2. So I have a positive 2x squared. Now notice here, I don't have a term. If it helps, you could put plus 0x because it just didn't have a monomial with a degree of 1 within that polynomial. So you're just really adding it to 0. You don't have to write in the 0x. Sometimes I do. So I have x. And then 1 plus 7 is 8. And this is my answer to this problem. Negative 5x cubed plus 2x squared plus x plus 8. Okay. All right, let's go ahead and try the next one. Now, when you're looking at these problems, I notice over here my highest degree is 4, so I have a degree of 4, 1, 2, and 0. And over here, I have a degree of 0, 1, 2, and 3. So I don't have a 4 over here, and I don't have a 3 over here. So sometimes I'll just be aware of that so that I can leave a blank spot when I'm writing them out. Okay, so I'm going to start with my highest degree here, and I have negative 2a to the 4th. And then I am going to leave a space for this one right down here. So I'm going to put plus 0a cubed. And then I have plus 3a squared for this one, minus 6a plus 5. Okay. All right, so now I'm going to come over here and write these. I have a negative 8. And then I have a plus, and I'm going to put a 1 there. It just helps me when I'm adding with negatives. Okay. And then I have an a squared, so I'm going to put plus 1a squared. And then I have a negative 5a cubed, so negative 5a cubed. And then if I want to here, I can just put a plus a 0a to the 4th power. Again, you don't have to. And I ran out of space, so I'm going to bring my answer up here. So I have a negative 2a to the 4th minus 0 minus 5 is a negative 5a to the 3rd power. 3 plus 1 is 4. Plus 4a squared. And then negative 6 plus 1 is a negative 5a. And then 5 minus 8 is a negative 3. Okay, and then that would be my final answer for that one. Okay, I'm going to show you a different way to do this because this just might not be your preference. It might be too much work or whatever. So what I will sometimes do is just put my, I will start adding my 2 highest degrees together and go down that way. So in looking at this one, I have a degree of 4 here and a degree of 4 here. Okay, so basically I have negative 7x to the 4th plus negative 9x to the 4th. Okay. Right, and then I have a degree of 3. So I have this one and I have this one. And then I'm going to add these. Negative 9x to the 3rd plus a negative 5x to the 3rd. And then I don't have a 1 degree here, but I do have a 1 degree over here. So that I just write that as minus 4x. And then I have a 0 degree here, so then I just put plus 4. And then I can go ahead and combine my like terms. So negative 7 plus negative 9 is negative 16x to the 4th. Negative 9 plus a negative 5 is a negative 14x to the 3rd. And then these had nothing to combine with, so I just have minus 4x plus 4. So this is just another way that you can do this as well. All right, we're going to move down to subtraction. Subtraction, there's only one difference, and it's in your very first step. And I'll tell you the way that the textbook teaches it to you, and then I'm going to tell you what I am actually doing in my mind. Okay, so I have 6x squared plus 4x plus 2, and I'm subtracting 2x squared minus x plus 8. So a lot of times people will just put one subtraction sign and write these terms below the terms here, but what you're actually doing with this negative is you're distributing a -1 to every term inside the parenthesis, and then you're changing it to an addition problem. So the way that I do this is I take 6x squared plus 4x plus 2, and I'm going to change this to addition. And I'm going to distribute a -1 to every term inside my parentheses. So -1 times 2x squared is -2x squared. -1 times the negative x is a positive 1x. And -1 times a positive 8 is a -8. So I've applied the negative to all the terms. I've changed it to addition. It's almost like when you're subtracting. Say you had a 7 minus a 15, and we say, okay, well, take this negative, apply it to the 15, and change it to addition. Basically, you're adding the opposite, so you get 7 plus a -15. That's really all we're doing here, turning it to addition. And then once you get to this point, then you follow the steps that we did up above. You can set it up into columns or a row. So up here, I did columns in the example and practice one, and then I did a row here. So you choose whichever way works best for you. Okay. So I have 6x squared plus 4x plus 2, and then a -2x squared plus 1x minus 8. Okay, and I end up with 4x squared plus 5x minus 6. Okay. All right. And we can go ahead and move on to the next practice. Now, if you don't want to have to rewrite the whole problem, you could just change your signs inside the problem. So if I change this to a positive, then this becomes a -3, a positive 2z squared, and a -7z cubed. But just be very careful that they're clear enough so you don't get confused and miswrite your numbers. Okay, so I'm going to write these in standard form. So I have 4z squared minus 5z plus 3 from this one. And then this one, I have a -3. I changed it to a -3, so I'm going to put a -3 right here. I have a plus or a positive 2z squared, so that will go right here. And then I have a -7z cubed. Well, I didn't put anything over here, so I'm just going to put that 7z cubed. And then we'll just put plus 0z here, and I'll put 0z cubed here. And now I can solve this. So I end up with 7z cubed plus 6z squared minus 5z. Now I have a plus 0 here, but you really don't need to put that plus 0 in your final answer. So I'm just going to leave my answer like this. Okay, so I want you to try this last practice one on your own and then check it with me once you're done. Use whatever method you prefer. I'm going to do mine, I'm going to do this problem using rows this time. So my final answer is 8m cubed plus m squared plus 4m minus 5. Okay. And that's what you should have gotten. Okay. We're going to go ahead and go to the third page. This is a different concept. We're not adding or subtracting. We're actually going to be factoring out. And I'm going to do 3 of these problems the complicated way, that it helps you understand what we're doing, and then I will do 3 the simplified way. However, if the simplified way does not work for you, because that would be what I would suggest to use if it makes sense, but if it doesn't make sense, you need to go back and do it, not the complicated way, but the longer way, okay? So what we're doing is we are factoring out, when we're factoring polynomials using the GCF, we're just factoring out the greatest common factor. So the first step is to write out the prime factorization for each of these terms, 9a to the 4th and b to the 7th. And if you need to, you can use a factor tree. Ultimately, this step is optional if you can determine the GCF without factoring or using a factor tree. I'm going to start off using the factor tree though. Okay, I'm going to take a drink of water first. Okay, so I'm going to factor out my 9 and my 12 to prime numbers. And like these smaller numbers, a lot of you can do these in your head. Okay, so there's my prime factor tree. Now I'm going to take each term, each monomial, and factor it all out. Okay, so I take 9a to the 4th, b to the 7th, and my coefficients, or my numbers here, are 3 times 3. And then I'm just going to spread out all of my variables. So I have 4 a's, and I have 7 b's. Okay, so I factored this first monomial out. Now I'm going to factor the next one out. 12a squared b to the 5th. And when I factored out 12, I got 2 times 3 times 3. I have 2 a's and I have 5 b's. I'm going to bring these down here. Okay, so we have completed step 1. We factored out each of the terms. And we're going to move on to step 2. Step 2 says circle the common factors between both terms. Okay, well, this one doesn't have a 2, so 2 isn't common, but these 2 3's are common, and so are these 2 3's. And then we have 2 a's that are common, and then we have 5 b's that are common. Okay, and those are all of our common factors. So that's step 2. Step 3 says to combine all of the common factors, and that is your GCF. So I have GCF here, and I have 2 3's, I have 2 a's, and I have 5 b's. And basically all I'm going to do is multiply them together. So a lot of you could have done this in your head. I have 3 times 3 is 9. I have 2 a's, so that's a squared, and I have 5 b's, so that's b to the 5th power. And so my greatest common factor is 9a squared b to the power 5. And that's how you pull out your greatest common factor the long way. Okay, but we're not finished, because not only am I finding my greatest common factor, my goal is to factor the whole term, the whole binomial. Okay, so I need to factor this whole thing. Okay, so we know what our GCF is. Now we have to figure out, okay, well, what's left out of each of those terms? Okay, well, in this one, the first one, we have 2 a's and 2 b's. And that gives us a squared, b squared. Okay. In the second one, we're only left with the 2. okay? Hold on. How did I have 2 3s in common? I think I did something wrong. Oh, this should have been a 2, not a 3. I'm so sorry. Okay, so let's go back. I'm so sorry. We only have 1 3 in common here. So this is not going to be 9. Maybe some of you caught that before I did it. So this should be 3. And this should be 3. So then when we come over here, we actually have 3 times all of that, which is going to give us 3. Okay. So 3 and then 2 times 2 times 3. Okay, so then over here, we're left with 2 times 2, which is 4. Okay, hopefully I didn't confuse any of you. So now we have to write out everything that we factored. So when you do that, the first thing you do is you write out your GCF. Okay, so write out your final answer by writing the greatest common factor on the outside of the parentheses. So 3a squared b to the 5th on the outside of a parenthesis. Then with the rest of the terms on the inside of the parentheses. So here's what's left over after factoring from our first term. 3a squared b squared, and then we're adding in our problem, so we put plus, and then 4. That's what was left here. And so this is your final answer for this problem after you have factored it out. Okay. All right, let's try example 2. Okay, so example 2, I'm going to factor out 18 and 27. Okay, and now I'm going to write the prime factorization of both of these terms. So for 18, I have 2 times 3 times 3, and then I have 4 x's, and I have 2 y's. Okay, for 27, x to the 6th y, I have 3 3's, 6 x's, and 1 y. Okay, so I did step 1. I wrote out the prime factorization for each term. Next, I am going to circle my common factors. So I have a common factor here and here. And I have a y that's common. Okay. So when I write my greatest common factor, I have 3 times 3 times 1, 2, 3, 4 x's. So that's x to the 4th and 1 y. That gives me 9x to the 4th y as my greatest common factor. Okay. So that's what I can factor out of those 2 terms. So let's see what's left once we're done factoring. We have a 2 and a y, so we're left with 2y with the first term, and on the second term we're left with a 3 and 2 x's. So that would be 3x squared. So now we're going to write that factored expression. So the first thing we do is we write our greatest common factor. And then in parentheses, we put 2y. Notice this time we're subtracting, so we want to put a subtraction symbol here. 3x squared. Okay. And that's our answer for this one. Okay, moving on to the next one. There is something that's a little bit different. The coefficient is a negative. So we're going to pull out a negative from the greatest common factor, and the reason is because when you write in your parentheses, the proper way to write it is that your first term is not negative. Your greatest common factor can be, but not the first term inside those parentheses. So I already know my prime factors for 4 and 6, so I'm not going to do a factor tree for those. I'm just going to go ahead and start factoring. So negative 4 m to the third n to the fourth p to the sixth is going to be 2 times 2, and then 3 m's, 4 n's, 6 p's, 1, 2, 3, 4, 5, 6. Okay. And remember, I said I wanted to pull out a negative here, so I'm going to have one of those 2's negative. Okay. And then we have a negative 6 m squared n to the sixth p to the fourth. And I have a 2 times a 3. And then I have 2 m's. I have 6 n's. And I have 4 p's. Okay. So now I'm going to do step 2 and circle my common factors. So I'm going to circle these. Now, even though this one isn't negative, because I want to pull a negative out of that first term, then I'm going to go ahead and circle that. And then I have 2 m's and 4 n's and 4 p's. Okay. So my greatest common factor is negative 2 times 2 times m squared times 4 n's, so n to the fourth, and 4 p's, so p to the fourth. So I can write this as negative 4 m squared n to the fourth p to the fourth, and that is my greatest common factor. Okay, all right. Now let's see what's left. We have 2, 1 m, and 2 p's left. We have to be careful with that. And then here we have a 3 and 2 n's. Okay. So when we write this, we have on the outside as our greatest common factor. And on the inside, our first term is 2mp squared. Now here, notice that we're subtracting, but I pulled the negative out of the term, and so I'm actually going to be putting an addition sign there. So plus 3n squared. Now, let me explain something really quick. If you wanted to go back and check to make sure your signs are correct, just check with your coefficients. Negative 4, did I do that right? Times 2 is a negative 8, not a 4. What did I do wrong here? Oh, you know what I did? I put 2 twice here, and I should have only put 1. Some of you are probably really frustrated with me. I'm so sorry. When you circle a group, it's just the one group. It's not those 2 numbers multiplied. I'm really sorry. Because I was like, wait a minute, that doesn't look right. Okay, so now, just to clarify, I circled one group of 2, so I can only pull out 1, 2. So I'm going to pull out the negative. Okay, and so so that's why that's here. Okay, so I have negative 2 times 2 gives me negative 4, and negative 2 times a positive 3 gives me negative 6. So I could go back and check those to make sure it's correct. And it's a good thing that I just did, because I did something wrong in my problem and I was able to catch it. Okay. All right, let's do this next example. Okay, now I'm going to show you the easier way. But if you prefer to do this way up here, that's fine too. Okay, so in looking at my three terms, I have 6, 8, and 2. And I want to know what my greatest common factor is between 6, 8, and 2. And many of you will be able to say, oh, well, it's 2. And you'd be right. Okay, the greatest common factor between 6, 8, and -2 is 2. And so, okay, I'm going to pull out a 2 from all of those. I can't pull out anything greater than a 2 because in this term right here, that's as big as my number is. And I don't want to deal with fractions in here. Then I look at x cubed, x squared next to the first power, and I think, okay, well, how do I know which, how many x's I can pull out? Well, it's the term that has the least degree of x's. Okay, well, this has a degree of 3, a degree of 2, and this one has a degree of 1, so I can pull out 1x. And that is how you find your greatest common factor without doing all the factoring and all that stuff. Okay, but then once you figure out your greatest common factor, okay, how do you figure out the rest of the expression? Well, it's like dividing. If I take 6x cubed divided by 2x, well, that first term becomes a 3. And then remember, when you divide with exponents, you're just subtracting them. So 3 minus 1 is 2. So I'm left with 3x squared. And that's what will go in here as your first term. And you continue to do that with each of your terms. So 8x squared divided by 2x. Well, 8 divided by 2, it becomes 4. 2 minus 1 is just 1. And so your second term is 4x. And then your third term, we're subtracting here, is 2x divided by 2x. Well, anything over itself is 1. So we put minus 1 like that. So that's the much more simplistic way of doing it, as long as you understand what you're doing. Okay, so let's use this method to do the next two problems. Okay, so I have a trinomial and I have 5, 25, and 45. So what is the greatest common factor in these three terms? Well, it's 5. And remember, since the first term is negative, I'm going to pull out a negative. Okay, so -5 would be the coefficient. And then I look at my variables and I have x's, they're all x's, and my smallest degree would be just this one. So the GCF for this is going to be -5x. Okay. And so then I am going to take each term and I'm going to divide it by -5x. So -5x cubed divided by -5x gives me a 1. Those cancel out. And then it's x squared because 3 minus 1. So basically I have an x squared for my first term. And it's positive because negative divided by negative is positive. Then I have 25x squared divided by -5x. Well, this becomes a 1 and this becomes a 5. And then 2 minus this 1 is 1. So I have -5x. And that's what will go here. And then my last term is -45x divided by -5x. That cancels out. This becomes a 9. And since it's divided by a negative, it's going to be a positive 9. And then my x's cancel out. So I'm just left with positive 9. Okay. Sorry, you guys didn't see that last part. Okay. The last problem, I look at my coefficients. I have a 1 here, 24, 12, and 4. Well, the greatest common factor is 1. So there's really not a coefficient that I can pull out. Okay, if it's 1, you don't have to write it. So then I look at my variables and I have a degree of 4, 3, 2, and 1, all of g's. So I can take out 1g from the whole thing. So my greatest common factor here is just g. Kind of funny. Okay, so then I take each term, g to the 4th divided by g, and I get g to the 3rd. Remember, you're just subtracting exponents. 24g cubed divided by g is going to give you 24g squared. And now you could probably see the pattern and not even need to do much of this. And then 4g divided by g just gives you a 4. Okay. So then I just write all of these terms, g cubed plus 24g squared plus 12g and plus 4. Okay. And that is how you factor polynomials. So there was a lot, especially on this 3rd page. So if you have any questions, please let me know, and I will be more than happy to help you all out. All right, you guys have a great day.